All right, everyone. Good morning. No hat this morning. It's pretty early, so I'm just kind of jumping in here and getting it done. So you get the messy hair. Hey, with the unit circle. So on Friday with assignment 5, everybody kind of got a little panicked because it was too much information. Remember what I said in that video, that there's a lot of information, but once you start working with it, it'll be easier and easier. So we're going to keep working with it, but I'm going to show you different ways to use it. So one of the tricks that I'll tell you guys, have the unit circle out with you, so that way you can reference it if you need to. I don't use the unit circle at all. I just I work with it, and over the years it's kind of become memory, I should say. But if you want to memorize it, you can. But you can write it down. I gave you the answers to the unit circle in the solutions for assignment 5. So I would print that out or fill one in and make sure that it's right, and then I would keep that with you at all times. But we're going to do it just like two examples today, talking about finding the exact value. That's value, not valve. Finding the exact value of the cosine of 240. So first of all, let's tackle this here real quick. I'm going to bounce backwards. Here's the steps. Draw it. Find the reference angle, which is from yesterday. Label your special right triangle. Find a trig function or functions they want. They just want cosine. So we're finding one value, and the word exact means it's going to stay in a fraction. Okay? So I do it this way. I draw my triangle. I go 240. Here's my x. Here's my y. I start at 0. I go around to 240. Remember, this is 180 degrees. This is 270. So then I just draw my terminal side of the triangle, and then I draw a perpendicular piece here to signify my right triangle. And then all I have to do, this is 240 degrees, all I have to do is figure out how far it is from here to here. So if I do 240 minus 180, I get 60 degrees. Well, on Friday, I said the most important piece about the unit circle is your special right triangles. So if we look at our special right triangles, I label the sides. Across from the 60 is root 3. That means this is 30. That's 1, and the hypotenuse is always 2. Special right triangles are that way all the time. 1, root 3, across from the hypotenuse is 2. So if we're looking at this, let me erase that. It wants, well, let me stop right there. This is the origin. I went left, so this is negative. I went down, so this is negative. X value is negative going left, Y value is negative going down. And so then I ask for the cosine. So now we got to label these things. So if this is my reference angle, we have opposite, we have adjacent, and we have hypotenuse. So what's the cosine of 240? Adjacent over hypotenuse. So the cosine of 240 degrees is equal to -1/2. That's my answer. That's all I have to do. Now, I'm going to lead you over to the unit circle. The unit circle. I go all the way around to 240 degrees. I look at my x value, because my x value is cosine. What does that say? The cosine of 240 degrees is -1/2. They're the same thing. You can calculate it, or you can use the unit circle. Okay? You can calculate it, or you can use the unit circle. It's up to you. All right? So remember, the x value is cosine, the y value is sine. So make sure you can show how to do it. I prefer this way because then I can find any angle and I don't rely on my memory. Okay, so that's the first one. Let's do another one. Let's find the exact value of cosecant of 5 pi over 6. Well, here's the problem with the unit circle. There's no cosecant or secant on there. You'd have to kind of manipulate it, and that kind of messes with people. And then people will be like, well, 5 pi over 6 isn't on the unit circle. Technically it is, except we need to convert it to degrees. So let's just convert this to degrees. So I'm going to convert to degrees, which is going to be the same as the cosecant of, let's do that real quick, 5 pi over 6 times 180 over pi. The pi's cancel. 6 goes into 8. 180, 30 times 5 is 150 degrees. So the cosecant of 150 degrees. So again, if I draw my triangle, drawing the triangles is crucial. This is my x-axis, this is my y-axis. Here's 180 degrees, here's 90. It's 150. It's 150 degrees. So I'm over here, but not quite to 180 yet. Draw my triangle. I've got to figure out how far it is from the x-axis to my angle. 180 minus 150 gives me 30. That's my reference angle. Special right triangle, 30, 60, 90. Across from the 30 is 1. I'm going up, so it's positive. Across from the 60 is root 3. I'm going left, so it's negative. Always across from the hypotenuse, it's 2. So I want the cosecant, which is going to be, cosecant goes with sine, hypotenuse over opposite, hypotenuse over opposite equals 2. There we go. So that's how you find the exact values. Use your special right triangles over and over and over again. All right. So here we go, guys. This is how they can use them. Engineers start messing with them. So I'm going to go ahead and erase the unit circle. So one of the examples says I have a ride. Let me get my, I have a ride. So I've got this tower here, and I've got this arm on it. So I've got this arm, and this arm spins. This arm spins right here, and it's got a big old piece on the end. You guys may have run, been on one of these rides, and this ride swings up and back. It never goes all the way around, but it gets as high as it can and then drops back down. Swing back down. So they give us some pieces of information about this. They tell us, so I'm going to erase this a little bit. You can draw, well actually I'll just draw a line through here. So they tell us some information. They tell us the arm is 84 feet. They tell us that it is 97 feet tall here. So from the middle to this is 97 feet tall. And they tell us that it swings from here. Let me get a different color. It swings from here back -200 degrees. Okay, so here's what we've got. We've got an initial side right here. It swings 200 degrees. As it swings 200 degrees, it stops. The arm out is 84 feet. And the height of the middle of the arm that swings is 97. So this is what I would do if I were you. If I were you, I'd just break this out and say, okay, look, I've got a triangle right here. So there's my triangle right there from the center. So think of this as a big circle. It's a big circle. So I'm gonna erase some of this. So I drew my triangle. I'm gonna erase a lot of the information. I'm gonna draw a couple of things in here for you guys. So I erase the arm, I erase the center, and then I'm going to draw the x-axis and the y-axis. And here is my standard angle. Look, goes backwards. It's just a negative standard angle. Okay? So, get rid of this. So look what I've got. I've got a unit circle that starts 97 feet up. Okay? So if I pull this information out, I still need one more piece. I've got this here. This goes back negative 200, so if I go halfway around, it's negative 180. What's the difference? Remember, this is negative 200 degrees. What's the difference between 180 and 200? Well, it's 20 degrees. So now if I pull this whole thing out, I have a 20 degree angle here, an 84 foot arm or hypotenuse. They want to know how high this thing goes, so they want to know how high the ride goes. I forgot to tell you guys that. So I need the height, but don't forget, it's already 97 feet tall. It's already 97 feet tall. So now all I got to do is find h. So I have opposite over hypotenuse. So if I have opposite over hypotenuse, that's sine. So I have the sine of what? 20 degrees equals h over 84 feet. So if I work the math out here, sine of 20 degrees times 84 feet. Get my calculator, guys. Sine of 20 times 84. I get 28. H equals approximately 28.78 feet, depending on how your calculator rounds. So now I know that this height here is 28.78 feet. So how high is the total? 97 feet plus 28.7 feet. So my actual height of the ride, actual height of the ride is 97 feet plus 28.78 feet for approximately, that's 29. 30 would be 126. Go back one would be 125. So 125.78. Right? Yeah, 125.78 feet. All right, guys. So when you're dealing with these, remember, draw it, find the reference angle. I found the reference angle using my swing that they give me. Draw the triangle you're working with, and then the last piece is make sure you understand that there's an original height on some of these. So it always boils down to a triangle, guys. All right, good luck, and we'll see you guys soon.